This is a transformer problem. Transformers are everywhere. My gosh, I don't know how many there are in the world, but they step up and step down voltages. Work in AC just fine, do a nice job. So here we go. The function of these black transformers, the little black ones that clog up your power strips, is to step down the voltage. So here we go, we have one, and let me draw this for you, because you can make a picture out of this. Here's a transformer. This thing is made out of iron, Fe for all of you chemical fans, and iron core to this transformer. And what happens is there's windings on this side, which is called the primary, and then there are windings on this side, which is called the secondary. That looks like so, primary and secondary. Great. Different numbers of windings will transform the voltages up and down. Okay, so now here's what happens. It says that we have on the primary side, it says 110 volts of AC. And it says on the secondary side, we have 6 volts, and there are 200 primary windings. 6 volts, and there are 200 windings. N1, the number of windings there. Now, how many windings are there on the second side, the secondary? Well, that's actually what we want to know. It says the number of turns on the secondary side. That's what we want to know. Right, and so here's what happens then. It says that once we have to have the number of turns on the secondary, we need some kind of physics principle. And the physics principle, in this case, is very simple. It says voltage across the secondary divided by voltage across the primary is the same as the ratio of the number of turns. So, wow, isn't that simple? Yeah, so if we're trying to find out what N2 is, then N2, according to this, it's N1 multiplied by V2 over V1. And so it says 200 turns is N1, 200 turns, and this has to be multiplied by 6 volts divided by 110 volts, and so we have just a plain number of turns here. It says 10.9 turns. So on the secondary there would be 10.9 turns. Okay, that tells you how to wind these things, and that's exactly what happens. How you make them is to wind them. Okay. Next, it says if this fax machine draws enough current to dissipate 8 watts, find the current that must flow in the primary. So this was part A. Part B says we're trying to find the current that flows in the primary. Well, there's another very interesting physics relationship here. It says that if you have an ideal transformer, the power in the primary and the power in the secondary are the same things. So you can say then that I1 V1 is equal to I2 V2. So what is it we're trying to find out? It says find the current that must flow in the primary. The current that must flow in the primary is our unknown. So then we do know V1, that's given. What about I2 V2? I2 is given, V2 is given, so we know all this. We can then find I1. It's I2 times V2 over V1. And so he tells us, actually, he says that there are 8 watts that flow in, that actually are dissipated in the secondary. So what's 8 watts? It's not a current. Currents are amps. Well, we also know that power is IV. And so I2 V2 is the same thing as the power. So then this is the power divided by V1. And the power, it says, is 8 watts divided by V1, which is 110 volts. And so the net result of all that is 7.2 times 7.27 times 10 to the minus 2 amps. So, how's our experience for us? Is that telling us anything about 7.27 times 10 to the minus 2 amps? It's not a very big current, because usually in your circuit breakers you need a 15 amp or 20 amp circuit breaker, so it's nowhere near anything that's going to blow our circuit breakers. So it looks like this may be okay. Now, one more thing you need to be aware of is that when you have those little black things that run your power strip, they indeed do transform from higher voltage down to lower voltage to run your low voltage electric appliances. But there's one more element to them also. Besides transforming, which is purely an AC function, they also convert this to DC. And to do that, there's another gadget inside there called a rectifier. That rectifier turns AC into DC. You can turn DC back into AC, but that's a different story. That one's called an inverter. And all these electronic gadgets are all over the place. They are ubiquitous. So anyway, this problem isn't going to deal with any more than just the transformer part of it, but it's enough to get you started. Okay.